Hello and welcome to helpyourmath.com. In this video, we are going to look at an example of simplifying expressions using the properties of exponents. Just to review the three properties that we're going to need for this video. First, we have same base multiplication. For same base multiplication, we'll add the exponents. Next, we have same base division. I actually do one of two things depending on what we're given in the problem. So if we have b to the x over b to the y, where x is bigger than y, so the exponent of the numerator is bigger, then I do regular subtraction. If there is a fraction and it's going to stay a fraction, then that base b with that new exponent would go in the numerator. But if I have b to the x over b to the y where y is bigger, then I actually will subtract away the x and keep it in the denominator, because there's a rule of exponents when we're simplifying that usually we don't want to have negative exponents, and this would be a way to just avoid that in one step. And the last property is power to a power. If we see b to the x to the y, we will multiply x times y, and that will be the new single exponent. Okay, so here we go. This is what we're given. The first thing we want to do is actually apply the distributive property, which is similar to power to a power. With the distributive property, any base that's inside the parentheses that has an exponent on the outside, we distribute to its exponent using power to a power. Bases do include numerical values, such as the number 5. So 5 has its own exponent. It has an exponent of 1. When we distribute, we're going to multiply 1 times negative 2, and we get 5 to the negative 2. Here we have b to the minus 4 to the minus 2. Minus 4 times minus 2 is positive 8. And c to the 7th to the negative 2. We would multiply 7 times negative 2 and get, we do not get b. We get c to the negative 14. Then in the denominator, I'm going to distribute that exponent of 3. So b to the negative 11th becomes b to the negative 33rd. And c becomes c cubed. The next thing that I like to do is anything that has a negative exponent will be positive in the position that it's not in. So if a base has a negative exponent in the numerator, it will be a positive exponent in the denominator. If a base has a negative exponent in the denominator, then it will have a positive exponent in the numerator. So I'm going to go ahead and switch those. So the 5 to the negative 2 will become 5 squared in the denominator. b to the 8th stays in the numerator, and c to the negative 14th will move down, giving me c to the positive 14th. b to the negative 33rd will move up, and c to the 3rd will stay where it is. And now, in the numerator, I have same base multiplication. There's two base b's, they're being multiplied. So remember what we do, we add the exponents, and we get b to the 41. In the denominator, we'll clean up the 5 squared, that becomes 25. And c to the 14th times c cubed, that's also same base multiplication. It's just taking place in the denominator, but that's okay. We're still going to add the exponents, and we do get c to the 17th. Now, this is the way that I do this problem. You don't have to switch them and make the exponents positive. You can still apply the same base multiplication, same base division, and still get the correct answer. This has been an example of simplifying an expression using the properties of exponents. Thank you for stopping by.